lot of you are here for what we have today. If I can actually track these things away, the joys of Zoom's UX. Tristan, how are you, sir?
Hey Rob, I'm doing great. I am super excited about this one. As you know, a lot of people at Hasura and people maybe who have been on previous community calls know, I'm a pretty big Python nerd. So we've got some really exciting stuff today, I think. You are able to host Python code now on Hasura's data delivery network, which is just insane, especially because, normally with GraphQL, it's strictly typed. And so you might be wondering, like, how does Python play into that? So super excited to actually start off. I've got a video that I think we're going to be able to share that'll kind of give a little overview of some of the functionality and capabilities. And then if we have some time, I'm going to jump into a screen share after and show off some federation stuff with Python. And we're going to start by jumping into a little bit of code. So with this Python connector, as we'll hopefully be able to see here in the video in a second, it's really neat. You're actually able to use a decorator here to register queries and mutations. And so in this example, we have an isExpired function that takes as a parameter a timestamp, which is a string, and it will return a Boolean whether or not the timestamp has passed, right? And so just to kind of give an example of what this looks like or how this works, I want to talk a little bit about relationships now. So when we talk about building relationships, right, with HTML, which is the Hasura markup language, we're actually able to define a relationship from a Postgres table where we have coupons to a function. So this is really cool, really powerful stuff. I'm going to switch my share. So as you can see here, we have the coupons table, which is from our sample database. And I have this is coupon expired field. That's actually a join from the database to the function, which is really, really cool. And what we also have with this is we have the ability to join not only from functions to or from the database to functions, but we also have the ability to do joins from the output of a function to the data, which we couldn't actually do that previously with Hasura v2, right? If you've ever thought about like action to action joins, or you've used Hasura v2's actions, this is really powerful because we can actually say, okay, let's take the output of this order response and say I wanted to build a function, Rob, that let me get the orders by status, right? Where I said, okay, here's a list of the statuses, and I want you to go get me all of those orders. Now, traditionally, you would do this with the Hasura query where you can use the where filtering, right? And you could say where, but let's imagine that that wasn't available. Maybe you're working with a weird data API, right? What we could do is we could create a function that would return this response here with a status that is a string. And then what we can actually do is create a relationship where we say, okay, we want to take the orders table and we want to have a array relationship on that get orders by status function. And so what's really cool there is we are able to, let me just switch this again. Sorry, a little bit switching around here. We're able to do something like this where now I can do this query get orders by status. And what I can actually do is it's performing a join from the function to the data. So really, really powerful there. You can imagine a lot of the capabilities that we're going to get from that. And then the last little thing I have to show off here, and then hopefully we'll be able to dive into that video, is the ability to you can also do function to function joins, and this is really cool. So as an example, I have this these two functions here. I have this function called chain, and I have this other function called chained, right? And what I can actually do is inside of the metadata, right? I can define a relationship where I can say, hey, I want you to take the output of one function and I want you to use it as the input for another function. And I can chain these functions together now. And that's Hasura doing all of the work. So the Hasura GraphQL engine and Hasura DDN is going to go ahead and allow us to chain these functions together. And if you look, of course, we get something that is lightning fast, and it's going to call the first function. It's going to grab this first piece of data and then pass it in as a parameter to the second function. So really cool, really powerful stuff. And now hopefully we've got the sound back working, because that is what I had for that demo. And now
Yeah.
we can maybe show off a little bit more of the capabilities and how you would go about writing some of this code and setting
Yeah.
things up.
We're going to do a deeper dive into these functions to demonstrate the different capabilities of the Python Lambda connector. We'll start simple by looking at the hello function. When you work with the Python Lambda connector, you'll make use of decorators to register queries and mutations. For example, you will use the register query decorator to register a function as a query. For example, this function will become this query on your graph. When you execute this query, it will call this function. Queries and mutations can be synchronous or they can be asynchronous. And it's also possible to pass optional parameters, such as in the nullable hello example, where, as you can see, the name is of type string or none and defaults to none, which turns into a query where you can call app nullable hello. And if I do not pass a name, then it's hello world. And if I pass the optional name parameter, then it will say hello Tristan. Since this is Python, it's also possible to leave untyped parameters, such as in this mutation called SomeMutation function. If I go ahead and run a mutation and call SomeMutation function, I can pass a parameter that is a string, or I could pass an integer or a float or even an array. You can also use pydantic models as inputs and outputs for your function. For example, this greetPerson function takes as a parameter a person model, which is defined here, and returns a string. The person model has a name and a pets attribute, which is a list of pet models. Let's look at what the GraphQL for this looks like. If we want to call app greetPerson, we can fill out a name, and pets is nullable. So if we do not add pets, it will say, hello Tristan, I see you don't have any pets. However, if I did have pets, I could add an array of my pets, and it would say, hello Tristan, and hello to Fido. Types can get quite complex, and they can be used as inputs or outputs for your functions. When the output of a function is a specified type, you can use GraphQL to specify which fields you want returned. For example, I can get all the fields from this function returned, or I can choose to only get some of the fields that I want. I can even make use of aliasing to change the response to look exactly how I want it to. The SDK makes it easy to do tracing using some of the utility functions that are provided, such as the withActiveSpan function, which allows you to trace your code. Here we can see that span we added, along with its attributes. You can also register functions to run in parallel.
So yeah, that's a little bit about the Python Lambda connector, Rob, and hopefully people are excited about it and going to be able to make use of it.
That's lovely. I know that we were talking a couple weeks ago. I was saying I haven't touched Python in a long time, so it's been quite a while since I've seen decorators for functions. But it's a nice thing to see a dynamic language like this now become statically typed. So well done, Tristan. Thank you so much.
Yeah, thank you, Rob.